Okay, everybody, hello and welcome for the stream. I see we have quite an audience today in the chat. Some folks saying hello to Sandra and Wajid. It's great to have you here. If anyone else would like to shout out in the chat, that'd be great. Hi, Daniela, how are you? And yeah, it's great to have you all here. So why don't we go ahead and get started right away? I mean, we don't want to lose any time, right? Yeah, I have a really exciting stream prepared for you all today. And it's about machine learning. And actually, machine learning has become such a big topic that, what do you mean by machine learning? That could mean any number of things. But in this case, we are trying to apply machine learning to gain data analysis and insights. So, in case of ChatGPT, maybe they're trying to help you be more productive and maybe also do some data analysis. But here we're really trying to do some prediction of an inference on your data. So that's going to be the subject for today. But before we get started, I want to have you please check in for the event. And I'll paste this check-in link in the chat as well. It's super important to us that we get everyone checked in because it's how we track our attendance and your interest and know whether or not folks are down for the kinds of workshops that we're doing. So please check in if you are able. Okay, I'm just going to leave this up for a minute so that you all can see. Okay, so hopefully you were able to get checked in. And I also want to share a survey with all of you. This is going to be just an intro survey. I want to get to know you better and know our community's experience. So please take this 5 minutes to complete this survey. All right, so hopefully you've had a moment to look into that survey. I'm going to actually see if we have any responses yet. I'm not sure. Oh, great. We already have some responses. So why don't we take a look at these together? And I'll share my screen and I'll show you what they look like. So we've had 11 responses, and of course, all is anonymous, so don't worry about that. But have you heard of machine learning? 100% of you have. How cool is that? Yeah, I think it's becoming so popular these days that it's hard not to hear about machine learning, to be honest. And then most of you, maybe 3/4 of you, have interacted with a machine learning model before. And honestly, to those of you who said maybe, that's a great answer because machine learning models are starting to become widespread in everything from credit card companies implementing them in their transactions to airline companies, Every industry is starting to use machine learning now. And so even without knowing it, you could be interacting with a machine learning model. So that's a great answer, maybe. And here's another one. Have you trained a machine learning model? Now we're starting to get into a little bit more of a breakdown here. We have half of people in the chat not having trained a machine learning model. And by the end of today, I'll be happy to say that you will have trained a machine learning model. So that will be an awesome accomplishment. And for those of you who have, hopefully this topic of transfer learning will be new to you, or at least a great refresher. Kaushik says, did I miss anything? You did not miss anything major, but we did already check in for the event. So I'm going to paste the link for the check-in. And right now we're completing a survey, an intro survey. I just wanted to get folks' experience level, some info about them. So if you want to fill that out, you're totally welcome to. And of course, 100% of you said that you're interested in learning new things about machine learning. So I'm so glad that you're attending this workshop today. And of course, if anyone has questions, please do feel free to reach out in the chat. I'm totally happy to answer those to the extent that I can. And it makes the whole experience better for all of us. So please do feel free to do that. Okay. And Global Hack Week is truly global. Just for fun, tell us which continent you're logging on from. I always love to see this because we have such a global and diverse community. It's just great to see that our messages are reaching around the world and that our community is growing. So we see such a diverse response here on many continents. So welcome in whatever time zone you're in. Okay, so back to our slides here. Sorry about that. I had to sneeze. I'm having a little bit of allergies here. It's now that it's spring where I am, but we did our survey, and now I want to talk about what is machine learning. And people are super, people are super surprised sometimes at the speed at which machine learning has arrived, or seeming to have arrived on the stage. And actually, the reason why is because of a convergence of two major factors. So the first factor is advances in statistical inference. And because we've had models such as neural networks, random forests, for many years, many decades even. They are not new inventions, although there are always new tweaks to the algorithms and new ideas coming up. But the basic machine learning algorithms are set for a long time. What's changed now is the access of fast computers. So you can now, anyone can go on Google Colab and get a GPU and 20 gigabytes of RAM on their GPU and another 30 gigabytes on their system RAM and spin up a really fast, high bandwidth statistical model. And that's a huge difference from before. These used to be things that could only be dreamed of or run on high performance computers that were accessible only by major governments and companies. So this is a huge advance. But it's not just enough to have this fast statistical model. Another big confluence had to happen here, another big factor, which is that large data sets are now accessible due to the internet. So the internet has created accessibility for all these data. We have satellite data, we have image data, we have people's tweets, and actually the internet itself is a source of data and has on the order of tens to hundreds of trillions of words that are trained, that are used to train large language models. So it's that confluence of these two factors which has created a burgeoning machine learning industry. There's some comments. So Coach says it's 2 a.m. in India. Yeah, I think this is sort of a slower time for Asia hackers, but I'm glad you're here, Koshik. And if any point you feel like you need to go to bed, I totally get it. You can always check these streams on recordings. So that goes for anyone who might have some other commitment or needs to take a rest. Feel free to catch the rest of the lecture, the stream on recording. And also, hello from Namibia. And yeah, super happy to have you here. Kinaja and Anj also, hello. Yeah, I'm glad you're super excited for the workshop. So we're going to talk first about what can machine learning do. And here's an example. So I have this diagram here, which illustrates one task of machine learning called classification. And classification is done based on what's called a feature vector. So a feature vector meaning it has multiple dimensions, and feature meaning that they are properties of the data. So for example, let's say we have some data on fruits, and each fruit has its own associated vector. And so it might have color as one dimension, size as another dimension, weight. We have all this information about the fruits. And then we could pass that in to a classification algorithm, a kind of black box, which we will use to tune an algorithm. And then the algorithm has possible outputs. So those possible outputs are discrete. For example, we have pear, apple, blueberry, and so on. So those are really neat. They're used for so many different applications. And here's one example of another example of classification. This is much closer to what we're going to be doing today. Oh, actually, I forgot to mention that one option could be a random forest. So a random forest is one algorithm that is natively supporting classification. Here's another example, image classification. So we could give as our feature vector the different colors R, G, and B, and the different positions X and Y of each pixel in an image. And using an algorithm, we can manipulate that feature data to generate a classification. So in the case of a CNN, convolutional neural network algorithm, that's a really common and popular implementation of computer vision. There's another task which is so common in machine learning called regression. And regression is prediction of a value. And it could be a number like 2, but it could also be a number like 2.1735, arbitrarily specific. That would be a regression because you're predicting some value, some float value that is continuous. And so we have this example from this paper, Mehta et al. They are doing a regression on the stock market to try and predict what the stock will be in the future. And so using regression is key here because the price of the stock can take on any value and is continuous. So that's the reason you need another algorithm. We talk about long-term short memory as one example here. And in that paper, if you're interested in that paper, let me actually send that along in case you're interested in reading it. But yeah, super cool application here. And I wanted to mention one other task, which is less common, and it's somewhat similar to classification, but actually it's almost its own distinct thing because it is working in a different way. So clustering. And clustering identifies quote unquote clusters of data. So we have an ML classifications algorithms workshop where we go into detail on this faithful eruption data set if you're interested more in learning about clustering algorithms. But the basic idea is that you have some criteria by which to sort the data, and then the computer will use its own not intuition. I guess that's a little bit too human, but it will use its own searching to optimize and find clusters that optimize those criteria. So in this case, we're using a spherical, not a spherical, an elliptical model. So you can just fit a little ellipse to each of these data, kind of like an oval that will make them clustered close together to two different ovals. All right, and generative AI is another super key advance in recent machine learning. And so you're imagining new things using user input as a prompt. And actually, I'm sorry, this is actually incorrect. I used to think that it was a type of regression. Actually, it's a type of classification, and here's why. Well, it actually depends on what you're doing, but the language model itself is a type of classification because you are predicting the next token. Okay, so it's called next token prediction, meaning given this this string that I've already predicted, what is the next thing that it should say? So there's only a certain number of tokens that are possible, so that would be classification. But in an image, you could think of that as a type of regression because the pixels can take on any value. So it's actually a little bit of both. And there are several different tasks that you can do with generative AI. But here's an example of one that is a regression where you are taking in a prompt, like the age, eyes, perspective, and mood of a person, and generating a face. And that's a really cool application. Okay, so let me actually send the research paper for this one as well. It's actually not a research paper. They did this in the New York Times a few years ago, and it almost seems outdated by this point, even though it was only in 2020. Now it seems kind of quaint to think about this being some limited use of generative adversarial network. But if you're interested, check that out. Okay, so the next activity we have planned is to think of a new use case for ML. And we've seen several examples in what I've shown, and we've even seen some new things. I don't know if any of you saw yesterday a new release of the ChatGPT framework, totally free to use, their latest model. And definitely check it out if you have not already. But yeah, what could you think of as a new use case that hasn't been discussed for machine learning? So let's give you, I don't think we'll take exactly 10 minutes, but I'll give you a few minutes, and let me send the survey in the chat. Here it is in the chat. And yeah, let's think about this for a little bit. All right, everybody. I hope that you were able to think of some new AI use case. This could be good practice, even just if you're thinking about starting a company or starting a new project. You know, there's so much potential now, I think, for developing new ideas and new value out of machine learning. So I think it's a great exercise. And don't worry, I won't steal your idea if you have one. But all right, let's check this out. So we have a few. Let's see here. That didn't work. Okay, there it goes. Yeah, so we have 5 ideas so far. Oh, 6. Okay, so this is very interesting. This last one, but I want to just talk about all of these actually. So first, how about fake news detection? Yeah, that's a huge one. I mean, you want to be able to know what is real and what's not, especially in this new age that we have. And yeah, so another one that is here is the spoken languages. So you have spoken languages being a huge new thing. Maybe real-time translation will one day become a thing. And then we have in healthcare for diagnosing diseases. Yep, absolutely. And that's already being put into practice. There are several FDA-approved cancer diagnosis algorithms that can be used to help tell you if you are sick or not. Writing news articles, yes, I think actually someone came out with a report that it's now highly likely that some major news sources are using, their writers are using ChatGPT to help them with their work. Image and photo to text description for individuals who are deaf or hard of hearing. I actually wanted to show a demonstration from yesterday that I thought was so cool. And let's take a look at that. Yes, ChatGPT 4.0 does this. So we're going to take a look right now.
Yes, it looks like the king is in residence right now. The Royal Standard flag is flying above Buckingham Palace, which is the signal that the monarch is present. How exciting to be there while the king is home.
Try and tell me exactly what they're doing right now, please.
Right now, the ducks are gently gliding across the water. They're moving in a fairly relaxed manner, not in a hurry. Occasionally, one of them will dip its head under the water, probably looking for food, and then pop back up.
I even know when a taxi is coming with its orange light on. I think I'll hail it to get home.
Yes, I spotted one just now. It's heading your way on the left side of the road. Get ready to wave it down. Great job hailing that taxi. It looks like you're all set to go. That's a good dog right there, leading the way into the taxi. Safe travels.
Okay, so what did you all think of that? I mean, what a cool application, and it's sort of similar to what you're thinking about. Oh, sorry about that. It's sort of similar to the idea you're thinking about there with helping out blind and deaf people. But I think this could even be another great way. So obviously, this technology still needs a lot of improvement, and and it's just getting started. So if you have an idea like that, definitely pursue it. Let's see, we have a situation where machine learning can help anticipate your final output based on your previous work experience and contribution, especially in the area of writing academic literature. Yeah, so imagine you already know a lot about the academic or the researcher and what they've already done and what they want to contribute. So you can maybe machine learning could help you plan out your future contributions. That would be great. And weather forecast. Yes, so now weather forecasting is getting to the point where these models are better at forecasting the weather in many dimensions, better than human generated physics-based models, which is really incredible. So yeah, thank you for sharing, everybody. These are great suggestions, but we're going to move on and talk a little bit about transfer learning. So this is a use case for machine learning that is actually not my idea. It's someone else's idea, and I've pointed you to their original paper. But the way that we tackle the problem is going to be a little bit unique in the fact that we're going to use a transfer learning application. So the classification is my banana ripe or not? And so well, why would you want to know this? You might want to know it if you are in the agricultural business or the grocery business or the transportation business, because you need to check thousands and thousands of bananas to see if they're good or not. And you don't want to have them bad ones in your grocery store. You don't want to ship them. And so maybe you would want to use an algorithm like this. Okay, so we're going to tackle this with transfer learning. And I'm going to talk to you now about what is transfer learning. And so using a previously trained neural net to extract certain features. So for this, you could have a data set that's trained on over 1 million images using a CNN algorithm, and then adding a final classification layer. So for example, gradient descent would be an example of a final classification layer. So this last layer is faster and requires less training data because the training data has been compressed using the pre-trained model. They're extracting these really relevant features, and then the rest of the data can just be thrown away essentially in that last stage. So that's why we have this diagram at the bottom. Pre-trained image model connects to the final classification layer, which eventually outputs a result. Okay, another really neat application. I'm not sure if this is machine learning related, but maybe it was. I'm not sure, but it's a really neat application for folks who are blind. So that is really, yeah, that's really neat, and maybe that could be somehow paired with the OpenAI API to make it even better. I'm not sure, but yeah. So thank you for sharing. Okay, so think about this as an application of transfer learning. And it's not really a perfect analogy because obviously computers and humans are two totally different things. But imagine that you are learning how to rollerblade and you're rollerblading in a parking lot, practicing that for a long time. When you go to learn how to ice skate, a lot of that knowledge is going to transfer over to your new task. And you're only going to need to learn a few smaller things, the differences between the two, in order to be successful. So it's not exactly the same thing, but it's following the same idea that you learn a skill. It takes you a really long time, and then you can maybe apply that skill to other areas. Okay. So we're going to have our first pop quiz now, and it's going to be checking your learning to see if you've been paying attention. And let's go ahead and take a look. I'm going to paste the link to this quiz in the chat. I'm going to give you 5 minutes to really look into it. Okay, everybody, I hope that was enough time to do the quiz. I always struggle because I don't want to make the quiz too long, so then you kind of lose interest, but I also don't want to rush you. So I hope that was enough time. But let's go ahead and take a look at the results. Oh, good, we have 13. So hopefully that's enough for now. And right, so here it is. And the first question is, I am getting so much spam these days in my email inbox. I want to build a machine learning model that will help me with this problem. The model should automatically detect spam messages so that I only need to look at real emails. This is an example of what kind of task? And we had almost everybody say classification task. That's exactly right. So we're going to want to know whether the email is a spam or not. And that's sort of right in the money house of classification. Now, a few people did say clustering, and I could see that actually, because think about how you could learn this task, right? In one way, we could say, okay, here's some examples. We could have a human say, here's some examples. Here's a spam, this is real. Here's a spam, this is real. I want you to tell me which one is which based on these examples. That would be classification. But if clustering was the case, we could just say, all right, here's two different types. We know that there's two different types of emails. And I want you to sort through and see if you can segregate them into two different types. And we could tweak that. Zamunda KE says, can the two models be used together? That's a great question. I think that would be a really neat idea. You have the clustering algorithm go through first and flag potential emails, and then maybe the classification algorithm could double check that, or maybe vice versa. That would be super neat. I think that's a great idea. And actually, I wrote checkboxes here because I don't want you to think that there's a right answer or a wrong answer. But yeah, those would be my two candidates, classification and clustering. Okay, I want to build a weather app which will tell me what the weather conditions will be tomorrow. And a few people wrote different things, but the overwhelming response was regression, and that's correct. And the reason why is because weather operates continuously. So what that means is that it could be 71, it could be 72, it could be 72.531, right? The weather is totally variable in that way, and there's no set conditions that you can pick from. So for that reason, regression and prediction is really what we want. And yeah, Shohink says multimodal already exists. So that is true, but yes, I've not seen, I don't, if anyone knows of how that's been applied in email, that would be interesting to me. I know it's getting more and more popular all the time. So thank you for that comment. And yeah, I'm sure you could accomplish this with transfer learning. As far as classification and clustering go, I think, maybe that's not quite right. I could see a few different things in weather, like maybe a thunderstorm warning. Let's say, should we issue a warning or not? That might be a classification, but most things in weather are pretty continuous. Okay. Next, I want to build an app which will recommend an outfit for me to wear, and the outfit should match my feelings for the day. And wow, we are all over the place on this one. People have all kinds of opinions. I do think that you could make an argument for any of these, honestly. Maybe you could use some combination of these models to really get at a good answer. But yeah, so I think generative AI, though, as we've written, that's probably the best answer there, because it will need to involve some imagination. Okay. Next, I collected seashells from 2 beaches. The only problem, they got mixed up in my cabinet, and I want to see if I can categorize them into two groups. And most of you said classification, it's transfer learning, but clustering was actually what I was looking for here, because I know that there are two beaches, but we don't have any training data. So I don't have a whole example of a bunch of beach shells from this one and a bunch of beach shells from this one. So I was kind of hoping that you all would choose clustering here, and many of you did. But yes, this is the idea here is clustering, and it's an example of unsupervised tasks. So we'll talk more about that as well. And why would you use ML for weather when that already exists? Meteorology. Well, the reason is that ML could potentially improve the weather, so weather forecasting. Shepnick says, rebuilding all these applications in the workshop. Oh my gosh, that would be one long workshop. We'd be here for a long time. But yeah, definitely leave it as a exercise to the reader. All right. So, well, thank you all for participating. And that last question brings us nicely into type of learning. So you want to select a learning mode based on your application. And there are two major modes of learning. There's unsupervised and supervised. Now, unsupervised means that we are not giving the human input for that. And supervised is the opposite, where you are asking humans to tag the data and giving them some kind of category in response. So let's take a look for some context. We have our fruit ripeness algorithm here. And that's supervised learning. So we're going to tell them, okay, this is a ripe banana, this is an unripe one, and give them a category. All right. And we have another quiz about this topic. So I want you all to try this one out. And I'm going to give you a few minutes to answer these questions about supervised and unsupervised learning. So here we go. All right, everybody. I hope you had a chance to look into that a little bit. And we're going to now take a look at the results of the quiz. I promise we're not going to have too many more quizzes. I know quizzes are a little bit, tedious for some people, but they're a really great way to check your learning. So we're going to go ahead and look into this result. All right, so it should be up on the screen. And the first question was undergoes a training period. And we want to know which one of them is it? Supervised or unsupervised or both? And actually the answer here is both. They're both going to undergo some kind of model training. The question is what type of training? Okay. And then the next question was relies on human labeled data. And for this, most folks did say supervised. And that is the correct answer because when you supervise a model, you can think of it almost like having a person supervising you at work. And if you could turn over to them and say, hey, is this right? And they can come back at you and say, no, that's not right. And then they go, how about this? Is this right? And yeah, that's right. So, you have a supervisor there to tell you what's the correct answer to get. Generally requires larger data sets to be effective. And a few of you did say supervised, but actually the answer here is unsupervised. So if a problem is unsupervised, it generally requires a lot more data. That's actually the case with ChatGPT and similar text models, foundation models. They require so much data, on the order of many trillions of data in order to improve. And their performance only gets better with more data. So that was our quiz. And we're going to turn back to our slides. And I did promise that we would stop doing this, doing these quizzes. And yeah, few shot learning. Okay, that is a good question. Few shot learning is a supervised technique because you're training for a few specific examples. That is supervised learning, and yeah, but that's a very good point. So there are cases where both is the right answer here. I guess the quiz is going now, but yes, good point about that. So let's go ahead and move on to fruit ripeness and computer vision. And we're going to talk about our ingredients, the ingredients we're going to need for this workshop. So first ingredient is pre-trained models. Super important, y'all. We're not going to train a mobile net architecture, which is a neural network for images on our own. We're gonna get it from the internet. Let's actually take a look at this model. I want to check it out. I guess this is on TF Hub, I think. I guess it's kind of hard to find. I'm not sure why I'm not able to find it right now, but this model is trained on millions and millions of images, which helps it to calibrate. And then its idea is that it can extract certain features from the image that are relevant to visual data. Okay. And for our data set, we're going to use this research paper published by Saranya Srinivasan and Pravin Kumar. They have created this really interesting deep learning ripeness identification, and we're going to try and get at a similar result, but using our own data. So I'm not using our own data, but using our own approach. So I'm going to paste the link to their article in the chat, and you can actually download the data from them, but I'm going to share it as well, so you don't have to worry about downloading it yourself. And we need a way to accurately represent the our classification approach, how it's working. Some people call this a loss function because it's mapping in real time what you want to optimize and how close you are to getting there. So we're going to use a confusion matrix, and that is going to represent the accuracy of our classification approach. The confusion matrix has several dimensions to it. It has first the predicted condition, and on the rows, the actual condition. And so we want to know when there are true results, so true positives or true negatives detected by the algorithm. So let's say that positive means ripe, okay? A true positive would mean that we had a ripe banana, and when we had our algorithm look at it, it predicted that that banana was ripe. A true negative is the opposite. So imagine we had a unripe banana, and when the algorithm looked at it, it said it was unripe. That would be a true negative. Then there are mixtures. So there are false negative and false positive. So for example, these are false results. Like for example, you could have a ripe banana that it seems unripe according to the model, and that would be a false positive. And then here's an example of a false negative. I'm sorry, that would be a false negative. And here's an example of a false positive. Imagine that the banana itself is unripe, but the model thinks that it's ripe. That would be a false positive. So we can represent the accuracy of classification using a confusion matrix. And we're going to get started now implementing this idea. So let's first go to Colab Notebooks, which is where we're going to do all of our machine learning analysis. I'm going to paste this link in the chat for all of you so that you can make your own account if you don't have one already. For myself, of course, I'm just going to go straight into it because I already have Colab. And it should bring you to this first page here. I'll show you that just in widescreen so that you can see. All right, so let's go back into this and on our slides, and we have a tutorial for transfer learning, and I'm going to open that up now, and we're going to walk through it together. Okay, so let's copy. I'm going to copy this and paste it and send it to all of you. It's a great tutorial by Google Colab, and we're going to adapt it for our own purposes. Okay. So here it is, application to fruit ripeness. I'm going to zoom in a little bit so that you can see better. Hopefully that's good enough. Maybe I'll put myself in the back so that you all can see really well. Yeah, that's what I'm going to do. All right, so I sent this to all of you, and it's going to be a tutorial for transfer learning adapted for our own use cases. So first, here's the license and everything. It's actually the TensorFlow Hub authors that wrote this. So TensorFlow Hub is a really neat resource where you can find all kinds of machine learning models, pre-trained models, data, publicly available data sets. And they helped to create this resource. So I'm just going to run that cell. You can see we're connecting into our environment here. And we're going to need to mount to our Google Drive. So I'm going to send you all this data set that I have on my Google Drive. It's super key. I hope I still have it on my Google Drive. I guess we'll find out in a minute, and I guess we could always re-download it from the research paper. But first, we're going to set up. So we are going to run and import all of these libraries. If any of these are unfamiliar to you, please let me know. But most of them have to do with data analysis and visualization. And this one here is TensorFlow and TensorFlow Hub. Those are really relevant for machine learning. And yeah, here's the drive. Oh, good. I still have it, I guess. I couldn't find it when I just searched for it. But luckily, it's still here. So I'm going to actually share this with you. You might be thinking, where is this banana data? It's not on my computer. Well, I just shared you the banana data. So go ahead and download that. You can copy it onto your Google Drive. So that should be super easy to do. Let me know if you run into any trouble doing that. But I'm going to break down this cell for you a little bit here. So we have first this directory. That's the directory where the images are stored. And actually, I'm going to go into these a little bit. Let's check it out. Here's my personal Google Drive. And when we click into banana data, we see that the categories are split into different directories. So actually, instead of just ripe and unripe, oh, access needed. Okay, thank you. Thank you, everybody. I am going to change the access permissions there so that it's anyone with a link. All right, so hopefully now you can get that. Thank you for being quick on that, Zamunda and Akinaja. That's really great. And let me know if there's any further issues. But each directory will be representing a different state of the banana. So let's click into one just to see the examples that they have here. Overripen. Let's see what this looks like. This better be a pretty ripe banana for it to be overripe. Oh yeah, that is definitely a very ripe banana. That probably doesn't taste very good. Yeah, let's see another one. Yep. Oh, that one is probably the worst of the ones we've seen. Yeah, pretty nasty. So you can see these bananas are a little bit too ripe for us to enjoy. And then these are green. So green bananas are also way out of the ordinary. We cannot eat those either. I mean, this one is okay, I guess, some of them, but it doesn't taste good probably. And they have mid-ripen. So these are pretty good, I would say. I think you could definitely eat those. And then yellowish green. Of course, yellowish green I think is the best. I always try to find yellowish green at the grocery store because that's perfect. I mean, you have a couple days to eat that and it's great, right? All right, so we have a few questions here. Would you choose pre-trained model before training? How are you actually doing it? That's a good question. So the idea here is to pick a model that will be pre-trained on similar data to the ones that you're going to see. So I'm going to actually show you later the model. I actually have the link here. Let me send it right now. Yeah, this is the link to our pre-trained model in TF Hub. And you can see, let's just look at this really quickly. This pre-trained model is used for image classification, image feature vector, and object detection. That's what Kaggle says. So those are tasks that we're interested in too, right? And so maybe this is a good one to use. It has a high usability rating. So that means that it's good quality. And you can see these are the kinds of things it can do. It can detect a table, a man, a car. And so that's the sort of thing that it can do. And it says it does not support fine tuning, but this is not fine tuning. This is something different that we're doing. Here's OpenImages 4. I don't know if any of you have ever seen this database, but this is the data that it is trained on. So you can see there are many image labels, 61 million image level labels, 21,000 classes. So if we look at these, it's a lot of data. So this is the kind of task we're interested in, and so it's kind of a suitable idea. Oh yes, Kaggle will also have models, just like Hugging Face. That's right. I guess now it might be Kaggle and not TF Hub, but TF Hub used to be the name. All right, so let's go back to our notebook here. I'm going to go scroll back up to here. We need to define our train fraction. So this is the next step here. Train fraction is meaning how much of the data that we have on our bananas is going to be used for calibrating our transfer learning model and how much is going to be used for evaluating them. Okay, so usually 80% training and 20% testing, also called an 80-20 split, is common. So that's why we're using it here. And the random seed here is just based on, whatever you want it to be, just to replicate the results. But you could theoretically just put this as any random number you want. And you don't even need to define a random seed. But we are going to use it. So, all right, now we're going to go into the function, make, train, and test sets. The idea here is to split the data into train and test sets and get the label classes. So here you're basically going through all of the files in the directory, and that's what this for loop is doing. The roots are telling us what are the classes, so that's what this if statement here is for. And you can sort them, enumerate them, and label them. So we have 4 classes, remember. Then the rest we get from our file names, and so we can sort the file names, shuffle them around, label them, and zip them into our training examples and our testing examples. So yeah, that's sort of how we're gonna divvy these up, and they get shuffled as well. So this function is going to return the train examples, test examples, and the relevant classes. Okay, so let's run this cell. I think I already did actually, but let's just make sure it's run. Okay, so now we download the images and split the images into train and test sets. You want to make sure you delete your download data. You don't need that anymore once you do that, but we are going to load those. So let's run it. Takes a minute, not too long, but you can see the output. So the data has 4 label classes, just as we said. There are 217 training images and 56 test images. So, if we were trying to train this model based on these 217 training images alone, it might not go so well, to be honest, because our model has such little time to learn over 200 examples. On the other hand, we're using millions and millions of pre-trained examples and applying to this new situation. So that's why it's going to actually work out quite nicely, we hope. And these test images, these 56 test images, we're going to save until the way end to figure out whether our data set works well, or our model works well, excuse me. Okay, so let's explore the data now. The flowers data set is what we're using. It has, the flowers data was the previous example, the TF Hub example, but this is actually going to be our bananas. So we're just going to generate 15 images here and display them. All right, so here they are. You can see that they each have a class assigned to them, a label, and some data. So our goal is going to be able to predict, going to be to predict these based on these real results. Can someone in the audience tell me, is this a supervised or an unsupervised learning task? Supervised or unsupervised? Let's see. What do people think? All right, Sandra says supervised, and that's correct. So thank you. Excellent idea, excellent work, because we're giving human labeled data, right? Where some human had to come and sort these into the different folders. And I also want to know, is this regression or classification? Okay, what is it? What type of task? All right, and Yokato says classification. That's exactly right. So we're doing a classification because it can only be one of these 4 types, right? It can't be some in between. We're not allowing the model to output that. It can only output one of these 4 classes. Okay. So let's scroll down and we'll build the model. So we're gonna load in this pre-trained model. It's the same one that I just showed from Kaggle. And we need to define a learning rate, some learning rate parameter. And the learning rate is a useful hyperparameter, what we call a hyperparameter. And it is indicating how quickly should the model converge on a configuration. So the lower your learning rate is, generally, the less risk there is that your model will quickly converge on some solution and overfit the data or misrepresent the data. But the higher the learning rate is, the faster the model will train. So there's a trade-off, right? If you make your learning rate higher, generally speaking, you can go faster. But you might overfit a little bit. So 0.01 is what we'll set ours for now, and you could experiment with how the result changes when you adapt the learning rate, but we'll use that for now. And we're going to load in this pre-trained model and process the images into tensors. And tensors with size expected by the image module, we need to get the expected image size from this module. So the pre-trained model goes on the OpenNet version 4 image database. All of those images have the exact same size. So we need to resize our bananas to be exactly the same as this one. So we decode the JPEGs to put them into 3 simple channels, not some decompressed form. And then we convert them into floats, and then we resize them. So TensorFlow has these awesome methods that allow us to do this super easily. But back before these tools existed, it was kind of tricky to use these pre-trained models. And now we'll batch the images in and basically apply them to the model. So we have features now in a variable. Okay. We're going to create our model. Our model is super simple. This classification model that we're building on top, it's just a dense layer, single linear layer. I don't know if any of you know what this is, but a dense layer is a layer where every neuron in the neural network is connected to every other neuron in the neural network, and they can adjust their weights accordingly and produce some weighted result, and in this case predicting one of 4 classes. So dense layer is one of the simplest types of neural networks that you can build, and it is actually what they call a linear layer. You can make it nonlinear by using an activation function, but we will leave that for another day. You're welcome to try it if you want. They give you an instruction on how to try it, but this is our really simple model built on top. It's going to be really fast, honestly, compared to a CNN, because there's not so much involved in it, but it'll still be really accurate, as we'll see. But did I run this? I hope I ran this. the last one. Yeah, I did. So we're still in the same little block. Okay, so we're going to make a score called the logits for these flowers, and the model outputs some real number for each of the features. So it might tell, oh, 75% chance that it's ripe, 80% chance that it's semi-ripe, 10% chance that it's unripe. Okay, and we want to label. So we're going to use a simple way of just picking whichever one has the highest probability and giving that to the class. And here is a optimization function, or a loss function, I'm sorry, that we can use. It's called softmax cross entropy with logits. And the idea is just to, again, you're trying to figure out which of these logits is going to, how many true positives we have, true negatives versus false positives and false negatives, essentially. This step here, the optimizer, is a gradient descent optimizer, and it needs that learning rate to tell how much drastic change, how drastic of a change it should do to that model after each iteration in response to the training. So, and then we'll once again try to use that to minimize this cross entropy mean, which is going to just be, again, how many positives and false positives and negatives are you getting. All right, and then finally, our probabilities we transform into a possibility, and we choose the highest one, as I mentioned, the highest probability for the class, and then we can check the accuracy at the end. So kind of a long thing to say. And oh, okay, I guess there's some error. I wonder if Gemini knows how to fix this. I think actually module might have been deprecated, which is unfortunate for our example. Let's try. We might need to use hub.load. That's what the internet is telling me. Let's see if that actually works. Who knows? And with these live demos, you never know what's going to happen. Sorry about that, everybody. Unfortunately, Gemini is not much help here, is it? Yeah, but this is also a good learning experience because, these things are changing so fast. You really need to check your codes before you run them. Get expected image size. Well, let's see if we can figure out what the expected image size should be. There's two. So it should. We can probably just manually do this. So let's try to manually do it. When we go to MobileNet, you can can see the size of the input image is fixed to 128 by 128 pixels. So if we go into here, we can just type 128, 128, and that should fix our error. Yeah, lots of issues, unfortunately. You can see it says that they are gonna get rid of this FN output signature. Let's see if that works. I don't know if that'll work. We'll see. Hope for the best. Yeah, sort of a bummer. Well, let's look at the revision history. I'll show you this a little bit here. I mean, there's a lot of stuff we could do. Oh, look at this. There's some I want to try this before we give up completely. Gemini so far has been not very helpful, unfortunately. Let's see. Yeah. Well, we'll have to go into the revision history. You all can do this too to check it out. But in a previous version of this, let's open it up. How about this here? You can see that we were able to, well, I guess it doesn't save my instance. But in a previous version, we were able to get this. Unfortunately, not today. So I'm going to have to try and look at that on my own. And I'll send you all a updated version here. But yeah, sorry about that, everybody. I was looking forward to it as much as you were, but our final reveal. But I think we'll just pause on that. And I'll get you in the second part, I will get you the correct response here. So stay tuned for our second installation. That's going to be Vision Transformers. We're going to look at Vision Transformers, and this one is a much newer, production that I've tested even just yesterday. So hopefully that will be a lot better. Yeah. Well, thank you all for joining today, and don't forget to check in. We will do the rest of this tomorrow at the Vision Transformers workshop. And you might be thinking, how do I get to the Vision Transformers workshop? Well, good question. You want to use the schedule, ghw.mlh.io/schedule. That's going to get you locked in. And if we look at day 6, there is Vision Transformer. And it's going to be this technical stream. I'll send the link in the chat. Okay, so go ahead and check that technical stream, making hacks with Vision Transformers. And it's going to be a really neat, also image related, computer vision related, but this time using a different approach from transfer learning. Okay, so we'll all take a look at that tomorrow. But yeah, thank you so much, and I hope you have a great rest of your day.